Ever wondered how Docker networking works? Well, hold on to your hats, because we're about to embark on a journey of discovery. Docker networking may seem like a complex topic, but it's a vital tool in the world of software development. Docker, for those who may not be familiar, is a platform that simplifies software delivery by making it easier to create, deploy, and run applications. And one of its most powerful features? You guessed it, networking. Docker networking allows containers to communicate with each other and with external networks, making it an essential aspect of deploying applications. It provides the flexibility to design and implement the communication architecture that best suits your application's needs. Whether you're a seasoned developer or just starting your coding journey, understanding Docker networking can open new doors and possibilities. So buckle up and prepare to delve into the fascinating world of Docker networking. Dive in to unravel the mystery of Docker networking. First, understand the basics of Docker networking. Docker networking enables communication between Docker containers and the outside world. It's the backbone that allows your applications to function and interact. But to make the most out of Docker, we need to delve into the three major types of Docker networks: bridge, host, and none. Let's begin with the bridge network. It's the default network for Docker containers. When you run a container without specifying a network, it automatically attaches to this bridge network. Picture it as a virtual switch, allowing all containers connected to it to communicate with each other. However, it has its limitations. For instance, containers can communicate, but they do so using their internal IP addresses, making it challenging to expose these containers to the outside world. Then we have the host network. In this mode, the container shares the network stack with the Docker host itself. It's like having a direct line to the host's networking environment. This means that the container has full access to the host's network interfaces and configurations, bypassing the need for port mapping, which you'd typically require in a bridge network. Host networking is efficient, but it comes with a caveat. It can pose security risks as containers have access to the host's network. Lastly, let's explore the none network. The name says it all. When you use the none network, your container gets its isolated network stack but doesn't configure it for any networking. It's like having a house with no doors or windows, completely isolated. This type of network is mostly used for testing or when you want to completely isolate a container for security reasons. These are the basics of Docker networking. Knowing what each network type does and when to use them is crucial in building and managing your Docker environments. It allows you to optimize your applications and maintain efficient, secure, and reliable services. Basic understanding sets the foundation for more advanced Docker networking topics. Explore the world of user-defined bridge networks. These are a type of network that you, as a developer, can create and manage within Docker. They offer a substantial leap in functionality and convenience compared to the default bridge network. Firstly, user-defined bridge networks provide DNS resolution. This means that containers can communicate with each other by their names, rather than by IP addresses, which can be quite a mouthful. This is a massive advantage when it comes to readability and ease of use in your code. Secondly, user-defined bridge networks enhance isolation. Each user-defined network provides a scoped environment for the containers. This means that only containers within the same user-defined network can communicate, shielding your containers from unwanted interactions. Creating and managing these networks is as simple as a few command lines. Docker provides intuitive commands for creating, viewing, and deleting these networks, giving you full control over your networking environment. User-defined bridge networks offer more functionality and convenience, so why not give them a try? Get to know more about host and none networks. Stepping into the world of Docker networking, one can't ignore the host and none networks. These two are built-in network drivers that Docker provides to control the networking of your containers. Let's start with the host network. When a container is run on a host network, it shares the host's network stack, and all interfaces from the host are available to the container. It's like the container becomes a part of the host itself. This is particularly useful when you want to expose the network services running in the container without any network translation. On the other hand, the none network adds a container to a container-specific network stack. That means no external network interfaces are available to the container and it becomes completely isolated. This could be beneficial when you want your container to be completely self-contained and isolated from external networks. Host and none networks have their own unique uses in Docker networking. Uncover the power of overlay networks. Overlay networks are a fascinating and essential part of Docker networking. Imagine them as virtual structures that overlay the physical network, allowing containers to communicate as if they were on the same host. They provide a method of connecting multiple Docker hosts into a single, cohesive network, even if these hosts are spread across different servers or data centers. Here's how they work. An overlay network creates a distributed network among multiple Docker daemon hosts. This network sits on top of, hence the term overlay, the host-specific networks. It allows one Docker daemon to communicate with others, providing the backbone for wide-scale, multi-host networking. But why are overlay networks so important? Well, they become a game-changer in multi-host and swarm mode scenarios. Let's delve into that a bit. In multi-host scenarios, overlay networks allow containers on different Docker hosts to talk to each other. This is a game-changer because, without overlay networks, communication between containers on separate hosts would be a challenging task. It would involve intricate routing rules and hairpin turns, but with overlay networks, all that complexity melts away. In swarm mode, which is Docker's built-in orchestration solution, overlay networks are even more critical. Swarm mode allows you to manage a cluster of Docker nodes as a single virtual system. The overlay networks enable containers in the swarm to communicate, regardless of the physical host they reside on. This kind of communication is essential for running distributed services and maintaining high availability and scalability. So whether it's connecting containers across hosts or enabling communication in swarm mode, overlay networks have got you covered. They are like the unsung heroes of Docker networking, working behind the scenes to keep your containers talking and your applications running smoothly. Overlay networks enable containers across different hosts to communicate. Take a look at the role of network drivers in Docker networking. Network drivers are pivotal to the Docker ecosystem, handling the networking capabilities across containers. They ensure that the containers can communicate and share data, enabling them to function as part of a coherent system. There are several types of network drivers that Docker utilizes. Each one is tailored to a specific use case, and understanding their functions can help you optimize your Docker networking strategy. The bridge driver, for instance, is the default network driver for Docker. It connects the containers on the same host, facilitating their interaction. The host driver, on the other hand, removes network isolation between the container and the Docker host, and the container shares the host's network stack. Overlay drivers, ideal for swarm services or standalone containers to communicate, create an internal private network that spans across all the hosts participating in the swarm. Network drivers control the networking capabilities of Docker. Familiarize with Docker networking commands. Now let's dive into the world of Docker networking commands. These commands are the backbone of managing and operating your Docker networks. They are like the secret sauce that makes your Docker experience smooth and efficient. First up is the Docker network create command. This command is used to create a new network. You can specify the driver for the network, its name, and other options. Next, we have the Docker network RMA command. Like a virtual eraser, it removes one or more networks. It's the go-to command when you need to clean up your Docker environment. Then comes Docker network connect and Docker network disconnect. These commands help you to link or unlink a running container from a network. Finally, the Docker network inspect command. It displays detailed information on one or more networks. These commands are essential tools for handling Docker networks. Recap the journey through Docker networking. We started off exploring the basics of Docker networking, highlighting the importance of understanding its fundamental principles. We then delved into user-defined bridge networks, where we discussed its role in container communication. Next, we moved on to host and none networks, emphasizing their unique features and when to use them. Overlay networks were our next stop, where we explored their role in facilitating multi-host communication. We didn't forget about network drivers, did we? We dissected their functionality and how they influence Docker's networking capabilities. Lastly, we went through Docker networking commands, equipping you with the necessary toolkit to manage your Docker networks effectively. It's been quite a journey, hasn't it? Remember, Docker networking is a vast field, and there's always more to learn. But with the knowledge you've gained today, you're well on your way to mastering Docker networking and optimizing your software development process. Master Docker networking to optimize your software development process.